Today I am speaking with VoxelRifts. VoxelRifts is a YouTuber who covers topics like C programming, compiler writing, and emulation, amongst other things. And he's also a very skilled explainer. I think he might have the most popular video on YouTube introducing programming in C with the arena style that I use in my own codebase. This conversation is structured differently from previous conversations I've had on the show, just due to geographical and technological constraints that we had on producing this. So each piece here, each question and each answer are going to be recorded separately, and we are trading these clips back and forth to ultimately stitch it together into the whole conversation. That does mean we'll be taking a little more time to prepare each piece, and we won't have quite as much freeform back and forth. So there are pros and cons to this format, but it's definitely worth it to have this conversation, so I'm glad we found a way to make it work. Big thanks, of course, to VoxelRifts for participating in this, and let's get to the first question. For my first question, I'd just like to get to know you a little bit and understand, how did you come to programming? What were you doing early on with programming, and what brought you to C programming in particular?
Hey Alan, great to be here. I would just like to preface my answer to your question with a big disclaimer saying that this is probably the weirdest way to start programming. Okay, like, I'm not even joking, it is so weird. I would say I started off in 4th grade when we were taught a programming language called Microsoft Logo. I don't know if you're familiar with it. It's a kind of programming language that is basically controlling a turtle. So you can there's a turtle and a canvas, and the turtle can move around on that canvas drawing some lines. You can give the turtle commands like forward 50 or rotate 90 and so on to draw geometrical shapes and patterns, and it's really nice. After that, in 4th and 5th grade, we were taught Scratch. At that time, it was Scratch 1.0. I believe we're at version 3.0 now. It's really, Scratch 1.0 was really old, but it's still really a solid concept where you can snap together blocks, and it's a visual programming language, and you can make animations and games using it. So that was actually really fun for me. I made quite a few small scale projects. I mean, what do you expect from a 5th grader? But yeah, Scratch was really fun. After that was, I would call, the first real programming language, which was QBasic, which is also made by Microsoft. I think it's run in an MS-DOS emulator or something. It's really old too, but it has all the basic primitives from normal programming languages like statements and arithmetic operations, and that's when we learned like the basics of basics, like taking input from the user and adding numbers together using programming and so on. At that point, I would say I still wasn't really feeling it, right? I didn't really enjoy programming much. I would do it because we were graded on that, but still I wasn't really interested. That changed when I learned about Minecraft and Minecraft modding. Since Minecraft Java is written in, you guessed it, Java, you can edit the jar file and add your own custom content. This stuff was really in-depth, and at that time, I think it was version 1.7.10 or something. That's when I actually started to want to learn programming through Java, because I wanted to make my own mod and add my own content. This was about 6th or 7th grade. Now, of course, you can probably guess that 6th or 7th grade me doesn't know a damn thing about what he's doing. I just had no idea what functions were, statements were, just I knew nothing about programming, and I decided to just jump into Minecraft modding, which is probably the worst idea ever. But I just did it. I searched on YouTube Minecraft modding tutorial and followed a series line by line and got a block to render, and that was really fun, I would say. Definitely not recommended though. Like, you should probably learn Java before doing that. This is when some rational part of my brain thought that, wait, if I would just follow tutorials blindly, I wouldn't really be able to make my own stuff because I'm just copying what the guy in the video is doing, not really useful at all. So I decided to learn Java at that point, not through a normal way like going to some classes or something. I decided to just wing it and just try to figure it out from the Minecraft modding tutorial. Definitely a terrible idea. Do not do this. But anyways, I did it. And I mean, at the start, I really didn't understand what was happening. But there was some point when I suddenly figured out that what functions are and how they worked. Like, function calls are directly related to their function definitions, and wait, if I pass something here, it probably goes there. That was a really massive aha moment for me, as you might expect, right? Like, me today would not expect 7th grade me to figure out what functions are, because I was just dumb back then. But still, somehow, by sheer luck, I figured it out, and that really hooked me, as I said. After that, I really wanted to learn programming, so I asked my parents to take me to a class, and I asked the teacher to teach me Java. When she said, Java is a really weird language to want to learn, I obviously would not say that I wanted to learn Java because of a game that I liked, but I just said, hey, I'll just like Java. But instead, she decided to teach me C, which is probably better for teaching the basics, right? And so for the next probably 6 months, I learned C. I wasn't really into it though. Like, I wanted to learn Java, and this woman randomly just started teaching me C. But whatever, right? I just learned, and at the end of the day, I still learned a bit of C. I would, at that time, make some connections with what I had already learned in Java. So I corresponded C's structs to Java classes. Even though they are nothing similar, in my brain, they were. That probably helped me a lot when learning C, and that probably still helps me when I learn new things, like corresponding to older things that I have learned. But anyways, I'm getting off topic. After learning C here, I went back and just decided to follow YouTube tutorials. I found out that there was this thing called Lightweight Java Game Library, LWJGL, which is a library which provides bindings for Java for common game development libraries like OpenGL, GLFW, OpenAL, linear algebra stuff, and so on. So I spent the next about 1 year learning that. And in that, I learned OpenGL and how renderers worked in the rendering pipeline and so on. At this point, remember, I had one indication that I should go learn C. That was the class teacher teaching me C instead of Java. But after this, after learning OpenGL and finding out that, wait, OpenGL and GLFW are all C libraries. And yeah, I know OpenGL is not a library, but, well, 9th grade me is not going to know that. Anyways, this was my second, I would say, indication of going to learn C. After that, I started and helped with a game engine project called Azurite, where I iterated on my rendering and learned a lot more about OpenGL and learned about frame buffers and all the graphics programming stuff. It was after this point that I learned that people could just create programming languages, or rather compilers and interpreters. it was this time when I found Randy as well, and a friend recommended me Handmade Hero. So there were two additional ways that pointed me to C. I still wasn't taking it seriously though, right? I was just focused on Java. So, anyways, I decided to follow the book Crafting Interpreters, in which Bob Nystrom implemented locks in C. So, after following the book in Java, I just went ahead and followed the part of the book that wrote the language in C. And that's when I discovered that I really had no idea how things worked, right? Like hash tables, dynamic arrays, just no clue how they were made. And I wanted to learn more at that point. I was really interested in programming because I knew I could actually figure stuff out myself. So in the end, I decided to just take heat from all of these past experiences that were just pointing me to C, and decided to just try it out for a little bit, see what happens. And that's where I still am, right? I'm still learning C.
That was a really interesting story. And there were a couple of things along the way that sort of paralleled to my own experience of learning programming. I definitely think, for instance, the early experiences of wanting to do game programming or game modding or ROM hacking or something like that seemed like a very common onboarding for very young individuals to actually start caring about programming. And that's something I think I want to talk about a little bit more later. But later on in your story, you captured really nicely a special moment that I think a lot of programmers go through when they're learning, if they keep on learning, that is, which is at some point you develop an understanding of some tools and you get really good at using those tools, and you understand them, or you think you understand how they work, and you do in a certain way understand them well enough to actually create things with them. But then when you find an opportunity to sort of stand from behind those layers or below those layers and understand that they actually had to get implemented from another perspective, that suddenly opens up a whole new vista of understanding. You suddenly can see that you didn't understand how it worked. And you were saying that this in particular for you was things like the data structures, the hash tables, and the dynamic arrays in Java were understandable to you in a certain way so that you could use them, but you didn't understand how they were being implemented, but you couldn't really appreciate that until you saw how they were implemented by Bob Nystrom in C in his book, right? And there's something really interesting about those moments when you finally see that you could stand below the layer you're currently at and understand how the layer above is constructed from below. That whenever I experience that, and it sounds like the same was for you, that once you see that, it kind of invites you in deeper. It asks you to come and understand more. And I think it's really fascinating how clearly you captured that moment, because I think a lot of times those moments, we experience them and then we kind of forget that we experienced them because the new understanding becomes just taken for granted again. But something about the way you told your story just now, I feel like you totally captured that magical moment of realizing there's something worthwhile to find by going deeper and understanding what you thought you already understood at a deeper level. So I really appreciate that. If we could stay on this topic of learning C for a little while, something I'm really interested in is trying to get an understanding of what does C do well and what does it make difficult? Because I think it's pretty clear to me that the more I lean into learning C, the better I feel about how I'm dealing with computers. And yet I can really see that a lot of people who come to it from different angles struggle. And it sounds like in your own story, it maybe wasn't that you struggled a lot with it, but you found it very uninteresting. Maybe you were struggling with it and you were glossing over that part. But I know a lot of other people do have that experience. And even people who eventually decide to get into it sometimes say that they get into it, but it feels more rough than the stuff they knew before. And so they value some of the power they get from it, and they value the lessons they learn, but they don't find it as friendly of an experience. And I wonder if that connects with what your own experience is, or if you would have a different view on how is C in terms of how difficult it is to get into and how difficult it is to master from your experience so far.
Right. So I think there's really two different types of barriers that you have to cross when either beginning to learn C or getting better at it. First of all, there's mechanical barriers and there is a deeper psychological barrier. So with regards to starting off with C, the mechanical barrier is it's just weird to get into. So if I had heard of these things called compilers, of course, at the time, because I was trying to write an interpreter, but I knew that there was this compiler for C called GCC. So I went online and searched how do I install it for Windows. Obviously, it's not really a Windows thing, but a beginner would not know that, and I didn't. So I just went through with whatever I was doing and had to install MSys2 and all of that stuff, and in the end it still didn't work right. So I switched to trying to install MSVC, which actually I already had, but I didn't know how to use the C compiler for it. And finally, after doing all this, in the end, I decided to just stick to Clang because I found a one-click download for it. I don't really understand why there's so many hoops that I had to jump through to just get a compiler. I just want to download something, install it, and write C code. But that's not what happens for some reason. So that was the mechanical part. The other part was a more psychological problem that everybody around you says that C is not a good language because I guess it doesn't have object-oriented programming, or it doesn't have the features that you want, or it doesn't have basic data structures. Now, this wasn't actually a big problem for me since I was actually trying to learn the data structures and so on. So this problem wasn't really in my mind. But if I were to recommend C to somebody, they would probably say to me, why would I learn C? Because it's just too bare bones, I guess, would be the right term here. So to summarize that, mechanically, really bad. I just couldn't get the compilers installed correctly at first. And the other, psychologically, it wasn't really a problem for me. Getting better at C, though, is weird because I think it's just the same as any other language. You have to practice and you have to be willing to look into things a lot more, I guess. But this is true for any language, I think. However, I do think there is a bit of a problem when it comes to more advanced explainers or tutorials online. There definitely are fantastic articles out there, but whenever you search for them, probably some C# or C++ or other C language name would come up before the actual C version. So that's definitely unfortunate. So I guess I would think getting better at C is a bit more difficult because of harder to access resources. But it hasn't really been a big issue for me because I just tend to experiment and find out myself. So to address what you said about people finding the language a bit rough and not really clicking with them or something, I feel like that's a byproduct of not having every single feature already in the standard library or something. Because I didn't really feel that. I started learning C to understand how things worked under the hood. So I didn't really feel that. However, another barrier for many people, I think, is memory allocation and doing that manually instead of letting the garbage collector or whatever pick stuff up, or using RAII or smart pointers or so, because people do rely on that a lot. So when I started off with C, I was also using the malloc free strategy until I watched one of Ryan Fleury's streams where he was using arenas everywhere. And I was, again, very quite curious. So I asked him, well, what is that? He gave me a pretty good answer. And I was referred to Ginger Bill's memory allocation strategies series, where I learned a lot more about them. And after understanding arenas and using them a lot more myself, I realized that when people were talking about memory allocation being difficult, it really wasn't. So this is just, for some reason, quite an unknown technique, but this really helped, let's just say. So when people think of C, they think of manual memory management, and they think of malloc and free, which is just, I mean, I get it because I also thought that, but in the end, there's definitely much better ways than that.
I think that's a useful observation, that you came to C specifically to understand how things work under the hood. And so you don't experience it as rough because of the things that you perceive as missing, but that someone who does perceive the language as being rough would probably also be someone who would like to have sort of more included in the package in some sort of way, so that they could start using more advanced data structures, right from the get-go. That definitely lines up with other conversations I've had about the introduction to C. And the mechanical part that you mentioned at the beginning there is also very unfortunate, as well as the entire sort of social block of having to find C resources, which are fewer and more buried than the C++ and C# resources. Those things aren't really the fault of the language so much as just the social condition of what's popular and what's not, but they definitely are a barrier to understanding it that makes it a little bit rough. It seems like you are getting something, though, from the process of learning C that you value. And if that's true, I suppose you would probably recommend it. I mean, you have made several videos trying to make C more accessible on your channel. And so I assume you would recommend it to some programmers who are curious. It's an interesting path, and I certainly would agree with that recommendation. So assuming we're in agreement there that learning C is a useful path to understanding computers better in a certain way, what would you do to make the onboarding process better? If you could hold someone's hand through the process, if you could set the expectations and sort of guide them into it. Obviously there's the mechanical stuff, so you might just start with saying, make the installation easier to understand. Are there other aspects you would massage about the language itself? Or we could think about it as leaving the language exactly as it is. What would you do in terms of an introduction to C? What kind of projects would you recommend? What level of programming experience do you think is appropriate? Is it a good first language? All of that. What is the right way to get someone into C who you think would learn a lot from it?
Okay. So first of all, yeah, I agree with you. I think people should learn C at some point in their life. But when they should learn C is a different and a much more difficult question to answer. On one hand, since C is so simple, it's definitely not the hardest language to start off with, right? However, maybe I'm just being biased here, but I think you appreciate a lot of C's simplicity once you've come from higher level languages and making over-engineered solutions. That may just be me, but I think I definitely appreciated C a lot more because I came from Java. So not really sure which is the better approach in this case. Now, about making the onboarding process easier, right, as you mentioned, making installation easier, making resources available, definitely very, very important. But apart from that, if somebody is to come from a higher level language to C, they will inevitably feel like it is way too bare bones. And now I kind of think this is a good thing because it forces you to learn about these lower level things that you normally take for granted. So I think an expectation has to be set there that you will have to implement a lot of things yourself. And that is not a bad thing. You will learn a lot. Now, with regards to what project you should do, first of all, if the person has some pre-existing project that they want to try, I would say go ahead. Doesn't matter how unrealistic it is. Just if it is really big and unrealistic, just be prepared to fail a bunch, right? That's fine. If you're working on what you enjoy, you will inevitably learn a lot more and be a lot more motivated than working on a project that some random guy on the internet just says you should work on. Now, if the person doesn't have an idea about what they should work on, I think, again, compilers, interpreters, they are a great starting project, I think. Especially if you just target an incredibly small language like, say, locks. If the person has already done a bit of graphics or something, and even if they haven't, if they just want to explore, Chip 8 is definitely one of the highest recommended from me because, boy, that project really has it all. Like, you're interpreting instructions, you're rendering graphics onto the screen, you're doing audio, you're doing timing. It's just a whole, it's a whole thing. So that's definitely another project that people should consider doing. Now, coming to a last question about how you would get someone into C, I think it's really different from what I've just been talking about. Motivating people to learn C is a really difficult question to give a general answer for. The reason is because, well, everybody has different goals, different motivations at first to learn programming and all that. But for some specific case, you could think about trying to connect to why they came into programming in the first place. So yeah, quite a different question, that one.
I find that whole thing really interesting, especially the kinds of projects that you're recommending people to do. Obviously, you said if you've already got a project in mind, that anyone who's thinking about learning a language should just do the project they want to do. But the fact that when you're coming up with projects that sort of seem like relevant introductions to the language, you're reaching for things like language implementations and console emulator sort of things like Chip 8. That's very different from my early days in C, and it seems in some ways much more connected to what C is really about. When I got into C, it was because I was sort of shifting down from C++, and when I got into C++, it was because I was trying to make plugins for the game engines I was working with. So I kind of came at it from this path of also coming down from a higher level, but along the way I was still trying to attempt the goals I had at the beginning for quite a long time. I was trying to make games, and then I was trying to make tools for making games, and then I was trying to make tools for making software, which, ultimately it was kind of heading in that direction. But it seems to me like somewhere along the way, you started feeling the pull towards language implementation and system emulation and things like that, those low level things, which are much more the historical wheelhouse of C. And I'm wondering, do you have any idea why it is that you find, like, what is it about those topics like language implementation and the Chip 8 emulator that really capture your interest?
Right. Maybe compiler slash interpreter is not really an ideal beginner project, but Chip 8 definitely is, I think. This is because, firstly, as I said, you have to do a lot of stuff like graphics, audio, timing, and all. But also because it's kind of like a simplified computer. So if you want to understand computers, it's a good way to get started, I guess. Because you're just like our computers are, your interpreter, Chip 8 interpreter, is going to be executing instructions, moving around stuff in registers. And once you get the hang of how bytecode and stuff like that works, you will probably develop a greater appreciation of C-like language features, like not having to specify registers and all of that. So maybe that was why I think Chip 8 is a good beginner project, right? Because I came to C because I wanted to learn a bit more about lower level things, and in doing so I needed to understand how the CPU does stuff, and this is actually a really good way to learn that. Since I did it recently, that is just fresh in my memory.
Right. But I guess I'm wondering if we set aside the question of what's a good project for a beginner and just think about what was your original motivation. So when you first picked up crafting interpreters, was there something in particular you were hoping to get out of the process of learning a language, or was it just curiosity? And then I wonder if you could give us some examples as you've been learning how to do things like, you've written a language, a C-like language now as a project, and you've worked on videos about parsers and how the compiler system works. What are some insights into programming in general and computers in general that you could point out that you've gotten from that path?
So, I mean, at the beginning, it definitely was just curiosity, right? I heard of so many languages, and the thought of making my own sounded like fun. Let's just say I wanted to implement my own ideas in a language and just mess about with things, right? So at first it was definitely just curiosity. As for what I learned from that, definitely the major thing was demystifying how compilers and interpreters actually worked. And everybody uses those, so knowing what happens under the hood, how expressions and statements worked, is a really good thing that I think is worth learning. Even if you don't want to implement a compiler yourself, you should probably learn about this stuff. Another thing was realizing that everything is just ones and zeros at the end of the day, right? Treating actual code as data for the compiler puts into perspective that it's just ones and zeros. It's just going to be executed by the CPU, which makes your thought processes a lot simpler, I guess. And the final thing that I would like to add here is that it made me rather enjoy C, because the stuff that people were saying that C makes you write unmaintainable code was just wrong. And I found that out. Maybe it's true for very, very big projects. My language wasn't that big. But at the same time, if you're putting off people from writing small projects in C, then you're really doing them a disservice in the end.
In one of your videos, you mentioned that not only were you working on a programming language, but you were working on a C-like programming language that got relatively far, at least from what it looked like in the screenshots. I wonder if you could tell us a little bit about if that's something you're still working on. Are you going in other directions? What sort of projects are you thinking about taking on in the future? And are you going for anything big, or is it more so exploring stuff that you can put on your YouTube channel, sort of where are you thinking of exploring in the future?
So about the language, I think I've pretty much done all I wanted to do with it. Actually, I did want to do a few more things, but I now looking back at it, I don't know if they're worth it. I'm not going to be converting it into an actual commercial language. Obviously, it's a toy project, it's a toy compiler, and I'm just not looking forward to fixing all the bugs on all the different platforms, I guess you could say. So, like, nothing more on the languages side, unfortunately. As for overall goals for me, right now I want to make a game and I want to publish it on Steam. I don't know how long it will take. I put a tentative deadline of 4 years. I don't know if that's too much, that's too little. I don't even know what game I'm going to be making. I want to make a game. That's a big goal of mine right now, because like I can make the systems, I can make the underlying structure, I can program, but when it comes to adding content, doing game design, I'm not good at it yet. I'm still working on that part. Now, when it comes to programming, however, I think I've been sitting in the middle all this time, like using C and Java. If people, I know people are going to be mad when I say this, but I would call using Java and using C being middle of the road, not super low level or not super high level. I want to go both ways. I want to try the crazy Android Studio stuff and React, Angular, insane web frameworks. And I also want to try going lower, learning assembly, x86, and RISC, and stuff like that. And I also want to try to make some hardware stuff sometime. I don't know how much of this will make it to the channel, but these are my overall goals for the time being. I've been working simultaneously on a little micromouse simulator thing, but I doubt that's really going to get to a YouTube video. So yeah, pretty much just working on smaller projects to try to understand more about what all we have at our disposal in the programming ecosystem, I would say.
Gotcha. Well, whatever parts of your projects do make it to the YouTube channel, I am excited to see them and see how they go. Speaking of your YouTube channel, I was wondering if you could tell us a little bit about how you go about making your YouTube videos. And maybe we could start with, how do you decide what topics are going to be covered, and how do you think about what you want to what sort of presentation style you want to put into those YouTube videos that you make?
Right. So firstly, I think it's clear from my channel that I have two different types of videos. One of them is just me doing some project and then looking at what I learned, maybe taking people to the journey of how I did it, maybe finding out some unique problems that I found while making that project, and so on, which is the devlog style, I would say. And the other style, of course, is the explainers, which I just try to explain a topic to the best of my ability, sometimes not very well. And those are structured, obviously, quite differently to the devlog style ones. So for a topic for devlog style, whatever project I'm working on at the time, I will try to convert it to some sort of timeline, say, where I did this stuff, then this stuff, and then just present it in that way. That's a done deal. It's not very difficult, I would say. But topics for explainers are much harder to come by, I say. I tend to help a lot on a few Discord servers where people ask questions and I try to answer them as well as I can. And many a times there's these recurring questions that pop up, or maybe just questions that are quite interesting, and I feel like the existing explanations on them on YouTube or on the internet are not sufficient. So like debugging OpenGL when people ask questions about why I see a blank screen in OpenGL. I mean, when trying to use OpenGL, there's like 10 different answers with regards to what it could be. So it can be really hard as a beginner to pinpoint what happened exactly, right? So from that, I got the idea for making the OpenGL debugging video. Or similarly, in the same server, somebody asked how math expressions could be evaluated. And since I had already done a lot of that when I was making my compiler, I kind of knew the general gist of it. And after digging a bit into that topic, I realized that, wait, the tutorials online don't really go that deep into this topic, which was the reason why I decided to make a video on it. So yeah, to summarize, I just say for devlog style videos, I just do whatever project that I'm working on and just present it in the exact same order that I did things in. And for explainers, I take frequently asked questions or questions with, in my opinion, inadequate answers online and try to explain them myself.
It's very interesting because I think my YouTube channel ends up having a very similar structure. I have devlog type videos and then explainers. But a big difference between my explainers and yours is that when I go to make a video that's not an explainer, I kind of go all the way out from hard topics. Like I don't have any real code involved, whereas you're still talking about things like writing a parser or dealing with OpenGL. So you're dealing with quite, concrete details, and my explainers are like abstract concepts of like different types of skills in programming or something. And I guess part of the reason why I do that is because I'm afraid that if I try to explain a concrete topic without a project that I'm doing to sort of back it up, that I'm not sure how I would keep it, from becoming a toy and getting certain details wrong because I'm not testing it against reality. And yet I think you do a pretty good job of explaining concepts, in sort of the hard space. So not, abstract notions about what skills to develop or different ways of thinking about things, but, how to write a parser without really having to have a full project there. And I think that it is useful to be able to have videos that are designed to be explainers like that. And so I wonder what kind of thoughts do you put into what makes a good explainer video for something like, say, your parser video? What makes a good explainer video in your opinion for a topic like that?
Right. So before I answer that last question, I want to talk about what you said before that, which is about trying to explain some concrete concept even though there is no project backing it, right? And on that point, I agree with you, actually. Because yes, it is hard to explain a topic if you have never used some of it in a project before. And so to pull back a curtain a little bit, I will just reveal that I have literally used all of the topics that I presented in explainers in different projects, actually. So for example, the parser, I use it obviously in my language, but majorly I use the same exact thing with implicit multiplication and all in my math sum 2 entry, which was a game. So on that point, yeah, definitely I agree that having a project backing your explainer is definitely going to help. So coming to your last question, that's definitely an interesting one. I really had to think about that for a bit. But I probably would not have come up with anything really groundbreaking by myself. But let's just say I had help, because every year there is a competition that is held online, which is called Summer of Math Exposition, and it's hosted by 3 Blue and Brown and James Schloss. The competition is about making math explainers. So just like computer science explainers, people make math explainers in a certain amount of time. And since it's a competition, there has to be some judging criteria for grading these explainers. And I think their criteria are genuinely really good for testing any sort of explanation, not just math. And I'll just read these criteria right now. They are clarity, motivation, novelty, and memorability. But I'll elaborate on these a bit. So, number one is clarity. Definitely big one. You don't want your explainer to be bogged down by too much jargon or anything. This is more of a problem with math explainers and math textbooks because there's a lot of information heavy syntax that is used in these explainers and textbooks, which can get overwhelming. So I just try to keep things as clear as possible and try to minimize jargon. There's places where jargon is definitely required, like say in my parsing video, I have to explain what a token is because that is quite fundamental. People have to know what that is, but anything that is not directly useful, like for example, if I just come onto the screen and say, oh, hey, look, we're going to be making an LL1 parser today. Nobody will understand what I'm saying, and it just gets too much sometimes. After that, I'll skip over number 2 because I think that's probably the most important, and I'll keep that for last. Number 3 is novelty, which definitely important because let's just say topic itself doesn't have to be completely novel. You don't have to be breaking new ground with every video, but you do want to try to add something that other existing resources don't have. For example, with my parser video again, I added the implicit multiplication part because for some bizarre reason, literally nowhere on the internet did I find any resource on how to do that. I don't know why, it just was, so I just added it. The fourth point is memorability, which, well, I just suck at this. I don't know how people make their explainers actually memorable. I keep trying. I don't know if my efforts actually work. But probably the biggest point that I want to talk about here is the second one, which was motivation. And I think this is the most important. Like, there's no ifs, no buts, no nothing. This is the most important thing to keep in mind when creating an explainer. Firstly, I think there's really two different types of motivation, and both of them are just as important as each other. First of all, the macro motivation, which is actually motivating people to wanting to learn the topic. Now, since this is on the topic of YouTube, we already have a big win because people only click on the video if they actually want to learn the topic. So they probably have some motivation at least. If we were looking at something like university, the teachers would have to do a bit more work there. But YouTube, since we are on YouTube, we are lucky. We still do have to kind of motivate people by trying to explain how this topic would be useful. And I generally do that at the start of the video, if you've seen. I try to show a concrete use case maybe, or just a cool something, just anything that will make it so that the topic, which is really technical, looks actually useful. Now that's one part, but we also have the second type of motivation, which is, I would call micro motivation. Let me be clear, these are not actual terms, I'm just pulling them out of the thin air. But regardless, this micro motivation, I would say, is the true meat and potatoes of a good explainer. Okay, I'll take an example. Let's say I was trying to explain to someone how the binary search algorithm works. There's really two ways I could go ahead and explain this topic. First way, that's the most common in universities, is I just come in and start saying, just start talking about the algorithm, right? Like, here we go. This is how the algorithm works. We have a top boundary and a bottom boundary. We take the midpoint of these two boundaries, use that as an index, and compare that with the number that you want. And then, depending on what the comparison output is, if it is less than the number, then we adjust the top boundary. If it's greater than the number, we adjust the bottom boundary. And finally, we just repeat that n times. And I would say there's also some conditions on this, that the array has to be sorted. That would be a full explanation technically, but it wouldn't really be helpful for people who are trying to learn the topic. Instead, what I would do is go step by step, right? Let's say I had talked about the linear search algorithm before this. Then I would say, hey, let's change one of these assumptions that we made. Let's say that the array is actually sorted and not unsorted. Can we make some optimization to our algorithm to not make it take so long, right? So I would probably go ahead and say, wait, since our array is sorted, can't we, instead of going one by one, can we go chunk by chunk in the array? Since we will know when we overshoot because the array is sorted. So then natural conclusion, natural follow-up to that is, what would happen if we overshoot? Would we go backwards? Or what if we run the same algorithm with a different chunk size inside the chunk itself? Then maybe figure out what the most efficient chunk size is. And finally, we literally just invented the binary search algorithm ourselves here. So these are the two ways of explaining a certain topic, I would say. And unfortunately, many online explainers, maybe many university courses and many teachers tend to adopt the first part, which is just exposition, just saying how things work, and people just have to learn things by heart. But you can probably see why the second option is far superior, because, well, like here in the second one, every single action that we take, every single method, every single step that we do is actually motivated by the last step. We can actually draw these conclusions from our base. We can actually do that. I think that is huge. That is so useful for explaining things. I think it's a shame that people tend to gravitate towards the first one just because it's less work. So to summarize, first one was clarity. Like, I tried to use as little jargon as possible. Second one, I said, was novelty. I try to add something unique to every single explainer. Sometimes I do that, sometimes I just fail at it. Memorability, still figuring that one out. I don't know how to do it yet. And motivation, giving reason for the topic to be explained here, and also giving reasons for every single step that you take. So yeah, super handy guide for all the people who want to make an explainer there.
Awesome. Well, thanks for giving us all of that info on how you think about explainers. I definitely appreciate that explanation that you gave just now of binary search and the path to getting to that, thinking through chunking. I think a lot of resources for learning give sort of problem setups and motivation in the sense of what's the problem, why is it useful to solve it, but you're also talking about sort of providing the tools for how to derive the solution in steps. And I think that a lot of people would benefit from being exposed to more and more the ways that people solve the problems that they solve, rather than just what is the setup for the problem and what is the final solution. So I appreciate that particular example of it, because I don't think I've ever heard someone show that path to discovering a binary search, and it's a pretty good path. So thanks. With that, I think we've had as many rounds of this as we can fit in right now. It is an interesting process recording it this way, and I hope we get to do more projects together in the future. You're definitely doing cool stuff on YouTube, and I think that your style is very unique on YouTube. You're taking on interesting topics, and you're doing a good job with the ones you're choosing. So I'm looking forward to seeing more, and thanks so much for coming on. Why don't you let everyone know where they can go to follow along with anything you've got coming on in the future?
Right, so my name is VoxelRifts. You can find me at youtube.com/@VoxelRifts. And I'm also quite active on Discord. My Discord server can be found in the description of every single one of my videos. Lastly, I do want to really thank Alan for inviting me to the podcast, because I've been following it since since it started, and it's quite surreal to be invited to a podcast where so many much more qualified people have already been interviewed.